Okay, so on Friday we started working with the binomial expansion theorem, and we used Pascal's triangle to start expanding some binomials, but we only got through 2 examples on Friday. So today we're going to finish the last of the examples. So get out your notes from last Friday, and we're just going to continue on the same set of notes with these. So starting with example 3, my binomial is 2p minus q, and I'm raising that to the 4th power. So to set up my binomial expansions, I am going to use Pascal's triangle. And Pascal's triangle, because my exponent is 4, I'm going to end up using this 4th row where the exponent is 4. So my coefficients are going to be 1, 4, 6, 4, 1. So I'm going to plug those in first. So I put my coefficients in first. The first one is going to be 1. And then I put a blank where I'm going to plug in the terms, plus. The next coefficient is 4, and a blank where I'm going to plug in my terms, plus 6, blank, plus 4, blank, plus 1, blank. So the first thing we're always going to do is fill in the coefficients. Next thing we want to do is start filling in the terms. So you always want to start with the first term, so 2p. But remember, when we have a coefficient in front of a term already, we need to make sure that we plug it in using parentheses. So when I plug in 2p, it's going to be in parentheses. And our first term always starts with the original exponent and then decreases. So this is going to be 2p to the 4th. The next one is going to be 2p to the 3rd. The next one will be 2p squared. The next one is 2p to the 1st, so I don't have to write the 1. And the last one is 2p to the 0, which comes out to 1, so we don't have to write that either. Then the next thing I'm going to do is I'm going to plug in the second term. Now this term is a negative q, so we want to make sure that when we plug in the second term with our exponents, that we attach that negative to it. So you always want to put it in parentheses as well. The first is going to be negative q to the 0, which is 1, so we don't have to write it. This next one is going to be negative q to the 1st, so we don't have to write the exponent 1. Then we're climbing up, so this is going to be negative q squared. The next one is negative q to the 3rd. And the last one is negative q to the 4th power. So we have all of the blanks filled in. And the last thing we want to do is start simplifying. So I suggest that you leave a little space right here so that we can plug everything in. So we first have 1 times 2p to the 4th. Remember, 2p to the 4th is the same as 2p times 2p times 2p times 2p. So 2 times 2 times 2 times 2 gives me 16. And then p times p times p times p is p to the 4th. And then times 1, so that's going to be 16p to the 4th. Plus 2p to the 3rd, so this is going to end up being 4 times 2p to the 3rd. That's 8p to the 3rd times a negative q. So when we multiply all of these together, this is not 4 times 8 p to the 3rd minus q. It's times a negative q. So this is going to be 4 times 8 gives me 32 p to the 3rd times the negative q is actually going to not make it a plus 32, it's going to make it a minus 32, and then we put that q at the end. So far we have 16p to the 4th minus 32p to the third q. So I'm not going to write the next plus in because it might turn into a minus as well. So let's see what happens here. So with my next one, I'm going to have a 6 times 2p squared gives me 4p squared times negative q squared. That's negative q times negative q. Negative q times negative q gives me positive q squared. So this is going to be plus 6 times 4 is 24 p squared q squared. My next one is going to be 4 times 2p to the first, so 2p, times negative q to the third. That's negative q times negative q times negative q. A negative times a negative gives me a positive, times a negative again gives me a negative, q times 2 times q, q to the third. So this is going to be minus 8p q to the third. So with our last one, when I'm multiplying a negative q to the fourth, that's negative q times negative q times negative q times negative q gives me a positive q to the fourth. So that's going to be plus q to the fourth. So I'm noticing that when one of my terms is negative, I alternated between subtraction, addition, subtraction, addition. So when you have a term that is negative, make sure that you are paying attention to what its exponent is, because it might turn out to end up being subtraction. And that's your expanded answer. So let's look at example 4. Example 4 is 5 minus y, so we have another negative here, to the third power. So I'm going to use that row of Pascal's triangle for the exponent 3. So those coefficients from the triangle are going to be 1, and then I fill in my blank, plus. The next number is 3, blank, plus 3, blank, plus, and then the last one is always 1. So that comes from Pascal's triangle, the third row. So 1, 3, 3, 1. So that's how we get those coefficients. So then let's plug in the terms. My first term is 5. So my first term always starts with the original exponent and then descends. So this is going to be 5 to the third, 5 to the second, 5 to the first, so I don't have to write the exponent, and then 5 to the 0, which comes out to 1. My second term is negative y. So when we plug it in, you have to make sure that you're including the negative. So that's going to be negative y to the 0, so we don't have to write it. Negative y to the first, negative y squared, and then negative y to the third. So when we start simplifying all of this, my first term is 1 times 5 to the third is 125. So that's going to end up being 125. I'm not going to put plus or minus yet because I had a negative term. This one is going to be 3 times 5 squared is 25, and then times negative y. So this is going to be negative times 3 times 25. So that's going to end up being a minus 75y. My next term is 3 times 5, and then this is a negative y squared. So that's the same as saying negative y times negative y, which gives me a positive y squared. So this is going to be plus 15y squared. So I went from subtraction to addition. So my hunch is that the next one is going to be subtraction. And I have negative y to the third. So that's negative y times negative y times negative y. A negative times a negative is a positive, times a negative again is a negative y to the third. So that's your expanded binomial. Last example. We have 2x squared plus 5, all of that to the 5th power. So I'm going to use the row of Pascal's triangle that has the 5s. So that's going to be this row, 1, 5, 10, 10, 5, 1. So I'm going to fill those in right now. So my first coefficient is 1, blank plus 5 blank plus 10 blank plus 10 blank plus 5 blank plus 1 blank. So we have our coefficients first. So the next thing we want to do is fill in our terms and make sure we put them in parentheses. My first term is 2x squared. Now the squared is only attached to the x here, but we still need to put the whole thing in parentheses. So this is going to be 2x squared to the 5th power. My next one is going to be 2x squared to the 4th, 2x squared to the 3rd, 2x squared to the 2nd, 2x squared to the 1st, so we don't write the 1, and then 2x squared to the 0, which comes out to 1. And my next term is just a 5. So the first one is going to be 5 to the 0, which is 1. This is going to be 5 to the 1st, 5 to the 2nd, 5 to the 3rd, 5 to the 4th, and then the last is 5 to the 5th. So let's start simplifying. This first one, 1 times 2x squared to the 5th. That's the same as saying 2x squared times 2x squared times 2x squared times 2x squared times 2x squared. So we're multiplying 2x squared 5 times. So I'm first going to work with the coefficients. So that's going to be 2 times 2 times 2 times 2 times 2. 2 to the 5th, which we already know 2 to the 5th comes out to 32. So we know that's going to be 32 times 1. And then I have x squared times x squared times x squared times x squared times x squared. We add up all of those exponents, which comes out to x to the 10th. And we can do this otherwise by, remember, distributing the exponent 2 to the 5th and x squared to the 5th. So 2 times 5 is how I get the 10. Plus. So here we have 5 times 2x squared to the 4th. So this is the same as saying 2 to the 4th, which is 16. X squared to the 4th, which is x to the 8th. So we have 16 times 5, which comes out to 80. But we also are multiplying it by 5 again because we have this 5 right here. So what we really have is 5 times 16 times x to the 8th times 5. So that's going to be 400 and then x to the 8th. So don't forget about this second term right there. Plus. Next one we have is 10 times 2x squared to the third. So this is 2 to the third, which is 8. X squared to the third is x to the 6th. And then we have times of 5 squared, which is 25. So we're going to multiply 10 times 8 times 25. Which comes out to 2,000. And then we have x to the 6th. Plus my next one is 10 times 2x squared squared. 2 squared is going to give me 4. X squared squared is x to the 4th. And then 5 to the 3rd is 125. So this is 10 times 4 times 125. Which comes out to 5,000. And then we have x to the 4th. Plus, you are allowed to use a calculator on this, by the way. We have 5 times 2x squared to the first, so that's just 2x squared. And then 5 to the 4th comes out to 625. So this is 5 times 2 times 625, which comes out to 6,250. Don't forget the x squared. Plus our last one, 1 times 5 to the 5th. 5 to the 5th is 3,125. And that whole thing is your expansion. So what I want you guys working on for the rest of the period is your homework. You have worksheet 1 from your green spiral book. And then you also have page 695 from the big textbook. Okay, so that's your homework that will be due tomorrow. And it's just more of these expansions. So you will be using Pascal's triangle to do these, and then we will collect that tomorrow.